Okay, welcome back. This is the second lecture in our Chapter 5 series. This topic is energy conversion and energy conservation. So, we talked already about kinetic and potential energy, the energy of motion for kinetic energy, and the potential to do work with potential energy, and the different forms of energy that there are: mechanical, thermal, chemical, electrical, electromagnetic, and nuclear. Now we're going to talk about what is energy conversion. It is a change from one form of energy to another. Simple enough. What are some examples of this energy conversion that you see many times during the day? First of all, we have the conversion of electrical energy from our lamp. The electrical outlet has the electrical energy, it sends it to the light bulb, and then the light bulb gives off light. That light is now the electromagnetic energy, that visible light that we see with our eyes. So that's one conversion, from electrical energy to electromagnetic energy. Again, in your body, you have all of those chemical bonds that are being broken, that chemical energy is released and transformed into mechanical energy so that you can move your muscles and play soccer and think, use your brain, use all of those activities that you do throughout the day, transforming chemical energy into mechanical energy. And lastly, if you took a hot shower today, then you transform the chemical energy from the water heater, from the natural gas, and converted it into thermal energy, the heat in the water. So there are many ways that we convert the different forms of energy into other forms that we can use. The next type of conversion is just between potential and kinetic energy. Sometimes we just convert from one potential to kinetic. What are some examples? First of all, juggling. Juggling, or at least throwing something in the air, is an example of how we can transfer potential and kinetic energy into those different forms. So if I have this orange and I throw it in the air and catch it, throw it and catch it, I am constantly transforming potential and kinetic energy. How am I doing that? As I throw the orange up, it has kinetic energy, it is moving. But as we see, it has to come down at some point. At the top point where the orange is in the air, it has all the potential energy that it's going to have. This kinetic energy is transformed to potential, and that orange now has all the energy and it can continue to do work. And it does. It falls back down to my other hand, and that's increasing the kinetic energy as it goes down. So again, it has full kinetic energy as I'm throwing it up. The kinetic energy decreases and potential energy increases. And then as it falls, the potential energy decreases and the kinetic energy increases. So we've transformed between those two forms of energy. Another example is a waterfall. Many of you have either seen a waterfall or have seen water moving. So you know that water always moves from a high point to a low point. Remember, potential energy has to do with the height at which it starts. So if I have this water, the only way it's going to move into this other cup is if it's above the other cup. So it starts at a higher gravitational position. And as I let the water go, that water is increasing its speed as it goes down to the other cup. So it starts off with 100% potential energy. And then as that water moves to the other cup, it increases its kinetic energy until it reaches the bottom and it has all the kinetic energy it's going to have. Again, we've transferred from potential to kinetic. Another transfer. Another form of transfer of energy is a pendulum. No, first we'll do the pole vault. First we have a pole vault, which you'll see a picture on your screen, or if you're following along, your book has a picture too. The pole vaulter, and you can see this in other forms, but for this example, this pole vaulter is running towards his goal, his mark. As he's running, he has kinetic energy. He's moving. He plants the pole down and it bends back, much like a catapult. He runs, he plants the pole, it bends back, and now that kinetic energy is transformed into elastic potential. Remember, elastic potential is when it compresses or bends and has that potential to do work. It then moves to kinetic energy until the man is at the top and the pole is straightened up. Now he's at 100% gravitational potential energy. And then that gravitational potential energy converts into kinetic energy as he falls back down to the ground. So again, kinetic energy to elastic potential energy, transformed to gravitational potential energy, transformed to kinetic energy. All of these in one simple, not simple motion, but one activity. The last one I was going to talk about is the pendulum. I have this pendulum. Oh, let me get my safety glasses, safety goggles of science, because I don't want to hit myself in the eye with my pendulum. So I've got this wrench attached to a string. Many of you have seen something similar, maybe not with a wrench, but some sort of swinging device, even in a clock. So if I have this pendulum and I start it out over here because it's eventually going to move, that's what I do. And as I do this, it has 100% potential energy at this point. It has 100% ability to do work, and also because it's at its highest point. What happens when I let go of this wrench? It's obviously going to move to the other side and swing back and forth. As I let it go, it has 100% kinetic energy at the bottom. There's also a picture in your book of this. 100% potential energy out here as I hold it. And then as I let it go, it has 100% kinetic energy down here. It's moving the fastest right here. And then as it goes to the other side, it has 100% potential energy once again. And then it continues to move back and forth, always having 100% potential energy at the edge, 100% kinetic energy at the bottom, and a mixture in between as it swings back and forth. Now, our next topic has to do with the conservation of energy. What happened, as you saw, my pendulum does not keep moving forever. It eventually slows down. Every pendulum you see will do this. It'll eventually slow down and stop. Why does it do that? What happened to all the energy in this wrench, in this pendulum? First of all, the law of conservation of energy states that energy cannot be created or destroyed. It only changes forms. So the energy was not lost to nowhere. It changed forms and was transferred to a different type of energy. So what types of energy did we have here? If you notice, there's the point, the fulcrum of this pendulum. It doesn't move, but the string is constantly moving back and forth at this point. Therefore, we are also creating heat. We're creating thermal energy as it moves back and forth and rubs against my finger at this point. So we're losing some energy as thermal energy, heat, to my finger. And also, as it moves through the air, we've learned about air resistance, or friction in the air. This wrench is constantly coming in contact with air molecules, and therefore that friction eventually slows down the wrench. So it went from potential kinetic energy to thermal energy from my finger, and then air resistance in the air. This is why your machines, or any machine, is not 100% efficient. Remember, friction causes the machine to lose some of its efficiency. And that's what happened to the pendulum also. It didn't lose the energy, it was transformed into the air resistance, that form of energy. Lastly, Albert Einstein did a lot of work with energy, and he came up with an idea that energy could be created by destroying matter. I don't want to confuse you too much, but all he thought was, and we see this in nuclear reactions. When we have a nuclear reaction, we split apart that nucleus. We actually end up destroying that matter, that nucleus, to get energy. So overall, our energy and our matter are not destroyed. They are conserved. What energy we get out of the reaction, that's what was destroyed by the matter. And so that's what Albert Einstein was saying, that matter can be destroyed as energy is created, but they are always, that total amount is still conserved. Again, if you have questions, don't understand something, write it down, ask me in class tomorrow. We'll continue to do activities with this section, hopefully to get you to understand more of these concepts. Have a good afternoon, and I'll see you tomorrow.